From Jason, who would be over here. Jason has a ponytail, so it'd be easier to see. So anyway, so I prepared some slides here, and what happened is you'll see is that, let me tell the story. Okay, so the Pixel, what was it designed for? Web apps, email, docs, media consumption to inspire an ecosystem. I think this was the original design brief. And I should tell you, the other thing that inspired me to kind of come out and really talk a little bit tonight was, I have a MacBook, but it's like an old one, and it died. And I was preparing to do the data flow workshop a couple of weeks ago. So I'd done everything to this Mac. I put an SSD in it, I put more RAM into it. It was just like old, and it was time for it to go. But I got this Pixel, so I'm using my Pixel now. So I was at the data flow workshop, and I was like, well, I need to do everything. I need to do all my development work with the Pixel, and it doesn't have a local file system unless you use Crouton, which is the ability to basically run Unix, and I think it's Ubuntu usually on the Pixel. So that's kind of like just a little bit of background. So here is the Pixel. This is what it was designed for, but that's not really what I'm using it for. And this is kind of like a little bit of the, this is back from 2013, you know, the Retina Pro. Pretty much everybody in the room here has got sort of probably a MacBook Retina, or maybe a good Windows machine, or maybe even a Linux machine. But you've basically got a file system on the machine. Well, and the specs, I noticed just some update from 2013 versus 2016. Main specs that have changed. I didn't update everything, but the main specs that changed is the battery life has gone up like hugely, from 5 hours to 13 life on the Pixel, and from 7 to 10 on the MacBook. And the prices went down a little bit, not that much, not as much as the battery life. The battery life went up really a lot here, and the price went down, which was kind of cool. And by the way, I do have my Pixel actually is the 2013 model, not the V2 model, which is currently shipping. So, all right. So I could do with being Jason at this point, because this is some of the stuff that on the DevOps side, you've got the secure shell, and you can do another issue we had was like key authentication. Actually getting the keys, this is one of the things you kind of struggle with if you've got a Chromebook, is getting the keys. The keys usually kind of want to come down to your machine, be moved from your machine, and provide authentication with your cloud console in the cloud. But when you don't have a local hard drive, that's kind of one thing you need to overcome. And then some other things that had started going on in 2013 was we got the emergence of really cloud IDEs, and a little bit more coming on that later because they've progressed quite a bit. Okay, a little bit more about DevOps here. Probably should say DevOps. But the main thing is if you've got a Chromebook, is you can use Crouton to get a file system on it by basically almost bootstrapping it with Unix, or Linux rather. So that's not what I'm doing. I'm kind of I'm doing some front-end work. So one of the things I really like to use is I like to use Carrot. So this is like Sublime on the Pixel. It's quite good. It's available from the Chrome Web Store. And this gentleman here, I guess Thomas Wilburn, he writes this, and it's kind of quite good. It's pretty much Sublime. It's very similar to it. It gives you a very empty IDE, and then you can colorize your so that your syntax stands out, which is quite good if you're doing what I find really useful. Another thing is Eclipse as recently, this was like just a couple of weeks ago, has now got a new version of Eclipse, kind of like a next generation of Eclipse, which is a cloud-based Eclipse. So something I happened to tweet out there was like, give me a bash or give me a cloud IDE. I prefer a cloud IDE. I don't really like to work too much at the bash prompt. So this is kind of cool, and it looks like it's going to have a whole ecosystem with plugins that actually plug into the IDE in the cloud. So one of the things that seems to be happening is that cloud, we've got the cloud, things like GCP, we've got the cloud, the Google Cloud, we've got other clouds. But the development, I think, naturally had been going on your machine locally because that's probably where it happened to begin with. But now it seems like the development is kind of moving into the cloud itself. So here's a little project I did recently, and this was I did this all on the Chromebook. This was after my MacBook had died off, and that was, I was like, well, I need to do some node work. And okay, so this was like my side-by-side comparison. This is what I would have, Chromebook versus my MacBook. On my Chromebook, I needed a file system, so instead of having a file system, I actually spun up a VM on GCP. And I spun up like the minimum VM because I want something that's like the least cost. I can just leave it there and use it when I need it. Because all I'm basically going to do is use it to install Node and NPM and do some configuration work on a GDX project, which is kind of like a Google Developer X, not Google X, but GGGX. We have like a bunch of hackers in the GDG world, and you create some interesting projects. And so once I got the VM spun up, then your VM usually updates, and I think updates with the latest Ubuntu. And then Nano is already there, so I don't need to install Nano. I can use Nano. I'm more comfortable using Nano than Vim. And then another little thing that happens is that early on, I think in 2013, as far as I know, this wasn't available, or at least we didn't discover it, was you might need to, what you need to do there was like to actually SSH and actually get some libraries out of Git directly into your VM in the cloud. And so the folks at Google have updated the GC util. I don't know, Paul probably set me right here. Maybe this was in here before. But anyway, you can basically, you don't need to. There's a small. I can load this up over here and just give some demo here. You can connect direct to Compute Engine instance directly with SSH. So, which is, and once you've done that, you can actually bring libraries in directly from GitHub onto your VM instance in the cloud. So you don't need to use your a local file system. That's the main point here. Another thing I found is that when you install NPM and Node, I found that when you do this on a VM, who knows why this is, but you've got a Stack Overflow. They don't actually link together. For some reason, you have to manually link them. Of course, if you do that on your local machine, they seem to just link fine. So you end up like with a properly working NPM environment. But for some reason, whenever they're done like on a VM, you have to run through this separate So that's one thing you have to kind of look up how to link them manually. So eventually what you end up with is you end up with a bash prompt. Well, I did anyway, a bash prompt on my Pixel, on my Chromebook, on the Google Cloud, and I've already got that set up now, and I don't need to come back to it. Now, one of the things I really like about this is that with Node, for sure, it seems like whenever I set up Node projects, they're very touchy because they're so close to the metal. Any sort of any library which is kind of slightly out of date doesn't work. And so once I've got something set up with Node, I'm really happy. So I've got now a few VMs set up, and I turn these VMs off once I've done my configuration work, and then turn them back on when I need to update. So so where's this going? I think this is kind of going towards. Diane Green mentioned something last week when she opened the keynote. She mentioned like better software faster, and sort of this idea of like. I know there's a bunch of DevOps guys in the room, so they'll probably not be too much into this. But for me, anyways, I want to actually try and avoid doing too much DevOps and more concentrate on actually building stuff. At the application side, so I want to be on more on the no-op side of things. And a couple of other IDEs I came across recently, or these platform as a service type things that you can use in conjunction with Google. I came across Metavine and Enterprise Web, and these are two pretty cool ones as well. So I'm currently doing some experiments there to actually develop some software for an AmeriCorps project, and deploy that on the Google Cloud, and then a bunch of actually food distribution centers that AmeriCorps helps will be able to use this application.
physical machine powered down. The one caveat to the it's a free machine, you're not being charged for the VM, but you are still being charged for the persistent disk image that we will then revive that machine from.
Okay, good, good. I can tell you something, it's not costing me very much at all. It's pretty, I can afford it. Yeah. A lot less money than the payments on a MacBook, yeah.
When you spin that back up again, the next time you want to use it, what has changed? I mean, are IP addresses or other things like that, your appearance on the network, did that all change? Or can you lock in IPs?
So I think by default your IP address may change in that it's like powering up a physical machine on a corporate network. You're going to make your DHCP call. Maybe you get the same address, maybe you don't. You can't count on it. Now, if you want to pin an IP address to a particular virtual machine, you can do that, but again, that's going to cost you money because you're now reserving that IP address. And I don't remember what the price is on that. You can look it up. And then the question is, do you care that so much about that IP address that you're willing to pay even when that machine's not running?
Okay, so I think we're done with Chromebook Give Me a Bash. We're ready for Paul's talk. How's that sound? Cool.
Does anybody need a bio break before we roll into it? Okay.
Thank you.
Thank you, Clyde. So I can't tell you what any but there we go. Customers. So we have 8.8 terabytes of customers. talk. So if you want to take a look at our data center through a cardboard, it'll be here for you. So that was our 360 tour. Let's go back and check on our query. Oh, good, it finished. So it looks like our query took 211 seconds. So I think that's a little less than 4 minutes. And you can see here 1.09 petabytes processed. So because we did a select star, we actually touched every single byte of this 1.09 petabytes. We loaded every single row, every single column, and we looked for stuff from this one sales order key. And we can see here we got our results. There were 12 rows. So we scanned 1.9 petabytes, or 1.09 petabytes to get 12 rows. So this is obviously not not a particularly efficient way to do this particular query, but it makes the point that we were actually able to scan every row of this data set, load it into memory, and take a look at it in less than 4 minutes. So let's see, 211, we'll call that 212 seconds, 1.09 petabytes. So 1.09 petabytes times 1024. So we've got 1,116 terabytes, and we scanned it all in 212 seconds. So we scanned that at a rate of 5.26 petabytes per second. Sorry, terabytes per second. So let's think about that for a second. You've got a 4 terabyte hard drive, and you want to scan through every byte on that 4 terabyte hard drive. I think that'll take you more than a day to just read every byte on a 4 terabyte hard drive. So you can imagine the massive amount of parallel I/O that was required to scan through 5 terabytes per second all the way across this 1.09 petabyte data set. So that's the first step of fun with a petabyte. But of course, we're not there. We're not done there. So let's have a look at what other games we can play. So here's a slightly more reasonable query. And what we're going to do here is, the big difference here, we're still looking for just, actually no, we're looking for one customer key. So it's not just one sales receipt. We want to see everything that happened with this particular customer. And we want to sum everything that customer did for each day. So what's interesting about this is we need to look at 3 columns: total sale, order date, and customer key. Those are the only columns that we've actually mentioned in this query. So let's run this. And again, we'll let that go, and I'll talk about something else. So keeping with the data center theme and how excited we are about data centers, we announced that we were going to be opening in 2 new regions. So you'll now be able to run your Google Cloud platform workloads in that Oregon data center that you saw a picture of and that you can tour around in our 360 tour. You can also run your workloads, or will be able to run your workloads in Tokyo. And we've announced that we're going to add 10 more regions in 2017, but we're not telling you where yet. Okay, was that long enough for the query to end? No, so let's talk about security. This was one of the keynote presentations, and this was my personal favorite, well, maybe my second favorite part of all the keynote presentations. This fellow, Niels, came on stage, and he walked through a wonderful presentation talking about the security infrastructure that underpins our cloud platform. And he basically, throughout his talk, he talked about the hardware and all the things you see on this row, and then he moved up the stack, up the stack, up the stack. I'm not going to try and reproduce what this very distinguished security engineer said. What I will say is I was super happy to see this presentation for a number of reasons. One, it was very, very interesting to me, and 2, he revealed details about how we do some of our security at Google, which previously I was not allowed to talk about, right? And now it's all there, recorded for you, and you can hear all about it in this keynote. So I highly encourage you. It was the second section of the second day keynote. I highly encourage you to go and listen to that presentation. It's got some really wonderful stuff in it. And our query story. So let's talk about machine learning. We made some announcements around machine learning. We were lucky enough to have Jeff Dean as part of our keynotes. It was quite a star-studded keynote. There was lots of big name recognition up there. So one of the nice things about what we announced about machine learning was we sort of filled out this spectrum that I have on the screen right now. So on the left side of this spectrum, we have TensorFlow. This is an open source project that was announced previously. And if you are using TensorFlow on a day-to-day basis, you probably already have a PhD or are working to earn one, and your focus is machine learning. It is a very, very high-end research community, open source type of project. Now, at the other end of the spectrum, on the far right, we have our machine learning APIs. These are models that we have built which can do very useful machine learning things, machine learning tasks for you. So an example is the Cloud Vision API, which can recognize useful objects. So one of the demos that we put together that shows off the machine vision API is this little robot. And it sort of comes up to you and you hold something up, and then it will tell you what it thinks it is. So you might hold up, it'll actually look at you and it'll say, you are, person. And then it might even try to infer your emotional state. So if you're smiling, it'll say, I think this person is happy. If you're scowling, it might say, I think this person is not happy. It can recognize common objects. Like if I were to hold up this water bottle, it might say literally water bottle or beverage or something like that. So it has these pre-made models which can do these useful things. Similarly, we announced a speech API which can do similar things for audio. You feed it some audio, maybe give it a hint as to what language it's expecting to look, and it will give you back, here's the the speech to text transcription of what was in this audio file. So very off the shelf, the kind of thing any software developer can use. If you can call a REST API, you can use what's on this end of the spectrum. And then the third thing we talked about at the conference was filling out the middle here, cloud machine learning. So this is where, for whatever reason, the prepackaged APIs with the pre-made models don't work for your particular machine learning application. So in the talk that introduced this, it was a wonderful talk by my colleague, Julia. Again, it'll be online soon. I encourage you to go watch it. And she put together a model which would identify, should I hug that? Which is, she actually sent an email around to our team and said, I know this is a little odd, but could you send me pictures of things that you would like to hug and pictures of things you would not like to hug? And then she fed these into and built a new model which takes a photo and then gives you an opinion. Should you hug that item? So this was something that the machine vision API nobody thought that we should have a hug factor in the machine vision API. But our colleague Julia thought this would make a wonderful demo of how, if there is something you want to try and detect in a photograph that the off-the-shelf model doesn't detect for you, this is an example of how you can train up a model to detect those things. And in this case, it was the huggability. So obviously, plushies and kittens scored pretty high. Cactuses were pretty low. There were some interesting results, which probably says more about the people on my team than the machine learning model. So I encourage you to go and watch Julia's talk when it is posted online. Now, let's see how our queries do. And our query is done. So the interesting number to look at here is, while there's 1.09 petabytes in this table, there's only we only had to scan 31.9 terabytes. I just used the phrase only 31.9 terabytes. I just like to call out the ridiculousness of that sentence. Only 31.9 terabytes was scanned for this particular query. That's because BigQuery stores its information, stores its data in a column-oriented format. So since there were only 3 columns named in this query, only the data from those columns had to be scanned. So that's why we were able to scan or query from this 1.09 petabytes and only scan 31.9 terabytes. Yes?
So retail petabyte is a table, and what is sales partition?
That is actually the entire. So the question is, retail petabyte is a table dot sales partition. What is that? So the answer is retail petabyte is actually the data set. If we look over here, and sales partition is the table within retail petabyte. So this here is what's called a data set. And these are other data sets that are available. These are all the tables that are part of this data set. And the data set is the unit of sharing. Like I can share a data set with you. I don't share an individual table, I share a data set with you. So that was cool. What else do we have? So now we're going to talk about this query. So here we're doing pretty much exactly the same query we just did. Excuse me. But we've added this section here, partition load time between 2005-01-04 and 2005-02-04. Excuse me one second. So here we're taking advantage of a new feature of BigQuery that was announced at this conference called partition tables. So in the old days, which is 2 weeks ago, we used to recommend that you don't have one big table with terabytes and terabytes of data in it. What you should do is break it up into a table per day. And then there was query syntax where you could say, here's the set of tables that I want to query from. Now we're turning that upside down. We're saying, you know what? We know the best. We know that partitioning your tables by day is a very useful pattern. We're going to make that a lot easier for you. So you now have one table, which internally is partitioned by day. And if you only want to query a couple of partitions instead of the whole thing, here's the syntax for doing that. So just like the previous query only queried a few of the columns and therefore scanned less data, this one is only going to query those columns for those particular partitions.
You actually create the partitions at the time of table creation time?
The question is, do you create the partitions at the time of table creation time? And the correct answer is, I don't know. I don't know how you specify the table. What I'm pretty sure is you don't have to specify an exhaustive list of partitions. You probably give us the cadence. It's like I want a partition per day, and then we make it a partition per day, depending on how you load it, like when you load the data.
And I tell you what the partition key is.
The partition key would be the dates.
Always date. I don't have flexibility.
I don't know. We'll have to go look. I'm now beyond what I actually know about this new feature that I just learned about last week. So this one took a lot less time, 9.2 seconds, and you can see it scanned only 266 gigabytes. So this is a way, one of the things, those who've used BigQuery before, this number is really important because that determines how much each query costs you. We charge you for how much data did we have to scan to answer your question. So this is really useful because if you know you just want this 1 month, the answer for this 1 month, now you don't have to scan your whole data set to get the answer for the 1 month. You only scan the data that you're interested in. So this is all great, but these have been pretty simple queries. It's been, filter out the stuff I don't care about, and then do some simple aggregations. So let's do something a little more sophisticated. And do this. So this query, we can see the whole thing. There we go. So first, let's look at this inner part, this inner query. What do we have going on here? So we are doing, again, we're scanning, we're using this timestamp feature, the partition feature. We're only going to look at 1 month here in 2011, January 2011. And we're looking for any sales order lines that match this regular expression. So this is now a more sophisticated query, that we're going to have to run a regular expression against every row that we fetch. And what we're trying to do is come up with the sum of those lines by date, and we're going to order it by the product and the order day. So basically, we're finding out how much of this thing did we sell on that day by product. Then up here, we're going to take that, how much did I sell of that thing on that day, and we're going to turn that into a running average. So this is give me the 7-day running average of sales for that product. So I get a smoother trend line instead of a really spiky one. But since I don't know how to read product keys, we're then going to join that with the products table, which has the names of the products in it. So this is so now we have not only an aggregation and a subquery, we now have a join as well. So let's give this a go and see how we do. And this is where I decide, do I switch back to my slides or do, oh good. All right, so 10 seconds, scan almost 2 terabytes, and we can see it's come up with the running average for these different products, all of which are fictitious names. And it's done that for all the products and for all the days of that month. So that's fun with a petabyte. If you want to see a much better version of this by a much more qualified speaker, go back and look at the talk that Jordan did. So what else do we have here? Nothing. That's it. So here are the links you need. The first one, the 360 tour, is the data center tour. Go have a look around. It's only about an 8-minute video, so it's not going to take that much of your time, but I think you'll find it worth your while. And then the second link here is the one where you should watch this space. First of all, you can access the keynotes that are already posted. There's also some interesting material in that that's already been posted of walking around the floor before the keynotes, so that you can see some of the other things that were going on at the conference. And then, of course, the 30 or so talks that have the deep technical content will also be posted here as soon as possible. I would be happy to take questions.